Hello and welcome everyone. Let's solve this medium LeetCode question today. So the title is search in rotated sorted array. There is an integer array nums sorted in ascending order with distinct values. Prior to being passed to a function, nums is possibly sorted at an unknown pivot index k, such as k is greater than 1 or equals and then less than the length of the nums, such that the resulting array is nums of k, nums of k plus 1 dash dash dash, and then nums of n minus 1 to nums of 0 1 2 then to k minus 1. So what this statement actually means is, suppose we are given with an array like this 0 1 2 3 0 1 2 4 5 6 7. Let's take it to a notepad. Okay, suppose we are given with this array, right? Now if the pivot is given as 3, let me take the marker. If the pivot is given as 3, that means wait, how do I make this smaller? Okay, if the pivot index is given as 3, then we have to rotate the array from here. What this basically means is we have to basically swap it to the left of the array. So if we swap 4 5 6 7 to the left of the array, we will be resulted with 4 5 6 7 and then 0 1 2, right? 0 1 2. As you can see, 4 5 6 7 0 1 2. Now they are asking for that given a target, we have to check if the target contains in the array, and if it contains, we have to basically return the index of it. Let's say 4 5 6 7 and then 0, it is index of 4, right? So the result should be 4 here. For this case, the target is 3, but there is no 3 in the array, so we have to give the output as -1. For this case, there is no target here, so you have to return with -1. Now there is a catch here. What is the catch? The catch is you must write an algorithm with big O of log and runtime complexity. Now when we are asked with big O of log n complexity algorithm, that means there will be something like binary search around it, right? Because if we do linear search here, we will find an algorithm with big of 1, right? If we do linear search here, but they are asking for log n complexity, so we have to think with binary search here. So how can we solve this problem with binary search? Now in generic binary search, if we are given with like if we are given with this type of array, right? 1 2 3 4 5 6 7, right? Now for generic binary search, the array must be sorted before we to implement the algorithm in the algorithm of binary search in the array, right? Let's say for this scenario, we are given with left here, right here. Then if we have to find like 5 from this array, what we will do, we will find the mid value here, which is 4, but our target value is greater than 4. So what we do, we know that our target resides to the right side of the mid, right? So what we do, we just eliminate all the values to the left, right? And then we work with this array 5 6 and 7, right? Then our new left is here, new right is here, our new mid is here. Then we again check that our target resides to the left of the mid value, right? So what we do, we just eliminate all the values which are to our right side of the mid, right? So we eliminate all the values to the right side, and then we left with 5, which is actually our target. Then we return. So in binary search algorithm, we basically eliminate one portion of the mid value, right? And then we work with the other portion of the mid value. Now for this scenario, which is this one, we cannot do the same case here. Let's say we are given, let's say this is the left and this is right, and our mid value for this scenario should be here, right? 7, and our target for the first example is 0, right? So our target is 0. Then we check that, but for this scenario, what we have to understand is, can we identify that our one side of the array is sorted? For example, let's say if we check that this portion of the array is sorted, then we can implement binary search algorithm for this scenario, for this case here, right? And then we would be easily find the target here. Or let's say this portion of the array is sorted, right? Then we can apply binary search algorithm for this portion of the array. So basically what is the thinking process is, we have to find one side of the array as sorted to implement the binary search algorithm. This is not actually a good example. Let's write another good example. 7, 8, 9, 0, 1, 2, 3, 4, 5, 6. For this scenario, let's say what should be the middle value? This should be the middle value, right? Our left is 0, and then our right is at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right is at 9, then left is at 0, divided by 2, will be left with 4, right? 0, 1, 2, 3, 4. So our middle value is 1, right? And our target value is 0. Now let's check here. If we check this portion of the array, is it actually sorted? Our left is greater than our right, our mid value, right, which is 1. Left is greater than or equals to our mid value. This is not actually a sorted scenario, so we cannot actually work with this one. But this one is sorted, right? Our mid which is 1 is less than or equals to our right, which is 6. So this portion of the array is sorted, so you can actually implement binary search algorithm in this portion of the array, right? So our first priority is identify. Our first priority is identify the sorted portion of the array when calculating the mid of the array, right? And then we see that for this scenario, as this is as this is our sorted portion, then we check our target 0. Does this reside in this portion of the array? It doesn't. So what we do, if it doesn't, we set our right to here, and we eliminate all the portion of this part of the array, right? And then we left with 0, 1, 2, 3. 3 divided by 2, which is 1. 1 plus 0, which is 1, right? So our mid value for this scenario is here. Now then we check that, then we again identify the sorted portion here in this scenario. So does L, which is 7, less than or equals to our mid value. It is true. It is true. If it is true, then we check that our target resides here. Does this reside here? It doesn't. So we basically eliminate this portion of the array, and then we set our left to here, and then we work with 9 and 0. And for this scenario, our mid value is, our left is here, mid value is here, our right is here, right? So in this scenario, does our left is less than or equals to our mid value? Yes, it does. And then we check, does 0 reside in between here? It doesn't. So we eliminate this 9 from here, and then we left with 0. For this scenario, our left is here, right is here, our mid is here, right? And then we check if it actually, left is actually less than or equals to the mid value. Yes, it is. And then we check our 0 resides in between them. Yes, it does reside in between them. And then we return our target value as 0, and then we return the index of it. So we are actually basically doing the same binary search, but in different way. We first identify our sorted portion, and then we do binary search without identifying the sorted portion. For example, this is not a sorted portion, 7, 8, 9 and then 0. So for this scenario, we cannot actually implement the binary search algorithm here, right? So our first task is identify the sorted portion of the array, and then implement the binary search algorithm in the sorted portion of the array. So let's write the code for it, right? Let's say initially our left is at 0, our right is nums dot size -1, right? And initially there will be mid value, right? While our left is less than or equals to right, we go for the implementation, and then we set initially our mid value as left plus right minus left divided by 2, right? Okay, divided by 2. After defining to this part, what we do, we actually identify the sorted portion of the array, right? So if our nums of left is less than our nums of mid, right? If it is true, then we check. If it is true, that means this is our sorted part, right? If this is our sorted part, then we implement the binary search inside this portion of the array. So what we do, we check if our nums of left is less than or equals to our target. We have to do one thing here, that is equals, right? Target, and target is less than or equals to nums of the mid value here. So if this is true, that means our target basically lives inside this portion of the sorted array, right? So if it does, what should we do? We have to do the binary search, right? So inside here, so we have to do the binary search. So we have to set actually the right. So our right should be set as mid minus 1. Now if it doesn't reside here, what we have to do, we have to basically set our left as mid plus 1. So by doing this, we are basically eliminating the sorted portion of the array, and we have to work further to the right part of the array, right? So this is one case. If it is not the scenario, or we can say like else if our nums of mid actually less than or equals to our, let's say, our right portion of the array, right? Then we have to implement the binary search algorithm to this part here. So if nums of mid less than or equals to our given target, and our target is less than or equals to our right side of the array, then what we should do, we should set our left as mid plus 1, right? And then if it doesn't reside there, we should set our right as mid minus 1. Yeah, and then we have to do the loop again for this scenario. Okay, now there is one thing that we missed. For any of the scenario, if our target is actually the mid value, then we return the mid, right? We return the index of the mid. Okay, so if we loop all through these, and then we see that we didn't find target in our array, then we return it as -1. This should be the code for it, right? Let's run it. The given it accepted. Yes, it beats. Okay, now what should be the time complexity here? It should be basically log n, right? Because we are implementing binary search here. Then we are traversing through the array. So it through the array and eliminating half of the array each time. So it should be big of log n, and then the space complexity should be big of const, as we are not storing anything here, right? Okay, thank you for watching. I hope you understood the code. Goodbye.